This is section 4.2, and today we're going to talk about the rest of our unit circle. So far we've covered the degrees and the radians. Now we're going to move into the things called the exact values. So this kind of goes back to geometry, where you're first introduced to trig and special right triangles. We're a 45, 45, 90, and then we have a 30, 60, 90. On a 45, 45, 90, that's an isosceles triangle, so both of these sides are the same. That's why they're both A's. And then your hypotenuse, when you actually do Pythagorean's theorem, comes out to be a square root of 2. So no matter what we put here, if we put a 6 here, this would be a 6, and this would be 6 square roots of 2. So in our unit circle, remember, we want our radius to be a unit of 1. So this would be our radius. So this would be a unit of 1. And if that were the case, then I would need to divide by square root of 2, divide by square root of 2, divide by square root of 2 to figure out what my other sides would be. So I'm going to get a 1 here, then I'm going to get square root of 2 over 2, because we can't have a root in the bottom, and then I would have square root of 2 over 2. These are where your exact values come from. So this is like your x value. Sorry, this is your y value. This is your x value. And the same type of thing happens in a 30, 60, 90. The proportions of the sides are a little bit different. Across from the 30 is a 1, and then the 60 is a square root of 3. The hypotenuse is a 2, but remember, we would like our hypotenuse to be a 1. So I'm going to divide that by 2. That'll get me my 1. I'm going to divide this by 2, so I've got a half. And I'm going to divide this by 2, so I've square root of 3 over 2. So in my unit circle, these would be the measures of my sides. Here's my 30 and my 60. And these are called our exact values, and that's what we're going to use down here. So your exact values really are just a manipulation of your regular triangle. It's just so that we want the hypotenuse to be a 1 because we are in the unit circle. So just as a quick recap, I'm going to go through and fill in the entire unit circle with, I'll start with our degrees and radians. So we've got 0, 30, 45, 60, 90, 120, 135, whoops, sorry, 150, 180, 210, 225, 240, 270, 300, 315, and 330. And I'm doing them fast because in the previous video I talked about all the patterns and how to figure all these out. So I'm just kind of filling them in. This would be 0 radians, pi over 6, pi over 4, pi over 3, pi over 2. Over here we would have 2 pi over 3, 3 pi over 4, 5 pi over 6, and pi. Down here we would have 7 pi over 6, 5 pi over 4, and 4 pi over 3. This one would be 3 pi over 2. Then we've got 5 pi over 3, 7 pi over 4, and 11 pi over 6. This one could also be 360 degrees. That would then make this 2 pi. And now we're going to talk about the exact values. So the exact values are literally, if this was the origin, how would I get to that point? So to get to this point, it would actually be 1, 0. To get to this point, it would be 0, 1. To get to this one, it would be negative 1, 0. And to go straight down, it would be 0, negative 1. So those are your quadrant ones. Those are usually kind of quote-unquote the easy ones. Now let's talk about our 60, our 45, and our, 30, 45, and our 60. So in your 45-degree triangle, in this one, we're talking about our x and y value to get to that point. So to go over, we would need a square root of 2, and to go up, we would need a square root of 2 over 2. So it's just a coordinate, remember, so it's just an x and a y. So it's square root of 2 over 2 and square root of 2 over 2. So whatever I go over has to be the same amount that I go up. So this is a 45, 45. These sides match just like that. So I'm just kind of replicating that there. Now we've done the whole rectangles thing, so all my 45s connect. And if this, just for simplicity, if this one over 7 up 7, this one has to go over 7 up 7. So whatever I had from x and y values, they have to actually be the same on every 45 I have. The only difference is in this quadrant, you're first going to have a negative because you're moving left, and then you're going to have a positive because you're moving up. So it's going to be negative square root of 2 over 2, and then square root of 2 over 2. In the bottom quadrant, quadrant 3, the values will be the same. I still have to go over and down the exact same amount. So the numbers don't change. All that changes is the signs. This one's going to be 2 negatives because you first have to go left and then down. So it's going to be negative square root of 2 over 2, and then negative square root of 2 over 2. Last quadrant, you actually go to the right first, so that's a positive, and then you go down, so that's a negative. So for this one, it's going to be square root of 2 over 2, and then negative square root of 2 over 2. So it is literally, you just start copying the values down. You start changing the signs in each quadrant. This one is a plus and plus. For your 30-degree angle, you want to talk about how far over and then how far up. So you'd have to go over square root of 3 over 2 and then up a half to get to that point. So square root of 3 over 2 and then a half. And then this has to be the exact same copy of that. So negative square root of 3 over 2 and then 1/2. This one has to have it so they're both negatives. So negative square root of 3 over 2 and negative 1/2. And then this one has to be square root of 3 over 2 and negative 1/2. So it is just copied. That coordinate is copied. You just change the signs as you go around. Last one is your 60-degree angle. So you would have to go over this much and then up that much. And really your 30 and 60s, they're just the flips of each other. So if this one was square root of 3 over 2 1/2, this one has to be 1/2 square root of 3 over 2. And then we'll make the first thing negative. And then we'll make them both negative. And then we'll make the second thing negative. And then kids are always like, oh my word, how am I going to remember that? Well, first of all, every single one of these fractions is over a 2, so that's easy. And then I always remind myself, if I start at the highest value, first quadrant, the highest value, and on the inside, it's actually a 1. And it goes 1 and then 2 and then 3. And then hop over and go 1 and then 2 and then 3. So they kind of match, or they have that kind of pattern. And once you know this quadrant again, you can just copy them. They're just copied from corner to corner. So now let's use that unit circle and let's actually tackle some sine, cosine, and tangent values. The sine value, if you remember from a long time ago, SOHCAHTOA. So sine is supposed to be the opposite over hypotenuse, which for us in our triangle would be opposite y, hypotenuse r. But since we're in the unit circle, we want our r to be a 1, so we'll be y over 1. So really, it's just our sine value goes with y. Cosine is supposed to be adjacent over hypotenuse. So adjacent would be next to, that's the x value. So x over r, and our r is going to be a 1. So cosine just goes with x. Tangent is supposed to be opposite over adjacent. And opposite for us is going to be the y, adjacent is the x. And nothing really changes there. Tangent is just y over x. So first one says, can we do the sine at 90? So just remembering that sine is the y value. I go to 90 degrees, I'm a unit circle, I want the y value. So it's just 1. Next up is sine at negative pi over 3. Remember that we can measure angles both positively and negatively. So a negative pi over 3 is really just go to where pi over 3 is and just go the opposite. So pi over 3 is that much, is 60 degrees. And I'm just going to measure that same amount, but I'm just going to go the opposite way. So I'm going to end right here. So really I'm looking at 300, and I'm supposed to give the sine value, which is the y. So at 300 degrees, the y value is negative square root of 3 over 2. Excuse me. Next up is 5 pi over 3, right there. And we're again doing the sine value. So I want the y value at 5 pi over 3, excuse me, which is negative square root of 3 over 2. Next up, I've got some cosines, and cosine's the x value. And the cosine at pi, so I'm going to go to pi, and the x value was a negative 1. Negative 7 pi over 4. I'm going to look at where regular 7 pi over 4 is, and then I'm just going to do the opposite. So 7 pi over 4 is all the way around this circle and 1/45 short of making a whole lap, or 2 lines short of making a whole lap. So go the other way and do the exact same amount of space. I would have to land right here. So I'm really talking about the 45-degree angle. And I want the cosine there, and the cosine is square root of 2 over 2. Next I've got cosine of negative pi over 4. I'm going to look at regular pi over 4, which is right there. I'm going to do the negative version of that, so that's right there. So we're really looking at 315, and I want the x value, so square root of 2 over 2. Now let's do a couple of tangents, which you can tell they take significantly more room here. First up is the tangent negative 7 pi over 6. So regular 7 pi over 6 is right there. So 180 degrees and one more line. So we're going to do 180 degrees and one more line. So we're really talking about 150. Now tangent is supposed to be y over x. So I'm just going to take the y value, which is a half. I'm going to put it over negative square root of 3 over 2. What's troublesome is I got a stack fraction here, and we don't deal with those, or we don't like to have those as an answer, so we need to deal with it. So I'm going to flip the denominator and bring it up. That will get it to cancel on the bottom, and at least now I won't have this big stacked fraction. I just have this one level kind of fraction. My 2's can cancel because I'm multiplying. So I end up with negative 1 over square root of 3. Oh my goodness. We know we can't have square roots in the denominator. So now we're going to multiply by square root of 3 over square root of 3. Multiplying straight across, I get negative square root of 3 over square root of 3 times square root of 3 is square root of 9, which is just 3. So that is the tangent of my 7 pi over 6. Sorry. I can't seem to clear my throat here. 4 pi over 3. So 4 pi over 3 is right here. We're still going to do y over x. So negative square root of 3 over 2 over 1/2. So right off the bat, I can just get rid of those. That's nice. We can flip the bottom and bring it up. So I'm going to flip 1 over 2 to 2 over 1. Cancel all that. I can cancel these 2's, and I end up with just square root of 3 over 1. Next up, I've got tangent at negative pi. So positive pi is right there. So negative pi is actually at the exact same spot. And the tangent is y over x. So 0 over negative 1, which turns out to be 0. Keep in mind that if you had negative 1 over 0, that would be undefined. And that can totally happen when you're dealing with tangents. So today was just a quick review in your exact values. Where they come from, where they come from is not hugely important to you. More like where they go in the circle, and then how to use them doing sine, cosine, and tangent.